Hello everyone. Today in this video I am going to discuss about motion and motion along straight line. So first of all, when you see around you, you find that either the objects are in the state of rest or they are in the state of motion. Now, how do we know that these objects are in the state of motion? If you see that the position of the object is changing with respect to any object, okay, so it means the object is in motion. Now here in this figure you can see that if the distance of this person is increasing from the tree, it means this with respect to time, it means this boy is in the state of motion. Okay. Now next thing is how to describe the motion. Now in the same example, the distance between the boy and the tree with respect to time is increasing. So here we have taken this tree as reference point. We are describing the motion of this boy with this tree. So here this tree will be taken as reference point. And whenever we have to describe the position of an object, we need to specify a reference point. Here the reference point is tree and it is known as origin. Now we'll discuss about the motion along straight line. But before that, let me discuss about scalar and vector quantities. Now in physics, there are some quantities which are described by specifying only their numerical values. If a quantity have only numerical value, okay, we are discussing about scalar quantity. If a quantity is having only numerical value, then it is known as scalar quantity. Okay. We have to describe these quantities with their only numerical values. Like if I am writing 5 kg, so here it will be a scalar quantity, and the magnitude of this quantity is 5. The numerical value of this physical quantity is called its magnitude. But whenever there are certain quantities which are described by their magnitude and direction both, then these quantities are known as vector quantities. Okay, now we'll discuss about the motion along a straight line. So let me take one very simple exam. Suppose this is the origin. Okay, now a car starts from here. Now this car is reaching at point A, and suppose it has covered 60 kilometer. So the total distance covered by the car, total path covered by the car is 60 kilometer. So this quantity is known as distance. This quantity is called as distance. The actual path covered by the car is distance. Now, in next case, if this car returns to point B after reaching point A, and the distance between A and B is, say, suppose it is 30 kilometer. So, the shortest path, the shortest path between the difference between point O and B is 30 kilometer only. So, the shortest distance between the O and B, the initial and final position is 30 kilometer. Now this quantity is known as displacement. Okay. So here in first case, the distance covered by the car was 60 kilometer, but displacement is 30 kilometer. Why? Because distance is a scalar quantity and displacement is a vector quantity. Okay, so here we have taken the direction also. We can understand it with one more example. Suppose a boy is moving in circular path. Okay, so this boy starts from point A and again reaches to point A. Now in this case, the distance covered by the boy will be equal to the circumference of this, that will be equal to 2 pi r, and displacement will be equal to 0 because the boy reached again at the same position. Now we are going to discuss some difference between distance and displacement. Now, what is the difference between distance and displacement? So it's a very important question. The first point is distance is the actual path covered by the object, and displacement is the shortest path. Okay. Now next difference is distance is a scalar quantity and displacement is a vector quantity. The next difference between distance and displacement, then that distance cannot be zero. Distance cannot be zero, but displacement can be zero. I have explained you in the example of circular path. If the object reaches again its at initial position, in that case the displacement will be zero, but distance cannot be zero. Okay, and one more very important difference, that will distance will be equal, it will be greater or equal to displacement. It cannot be less than displacement. It will be either greater or equal to. Suppose an object is moving in a straight line. It started from point A and reached at point B. Now in that case, what will be the displacement? What will be the distance covered? Suppose it is 10 kilometer. Now in this case, the distance is 10 kilometer and displacement is also 10 kilometer. Okay, now object returns again in the backward direction. It reaches at point C, and suppose the distance between B and C is 4 kilometer. Now in this case, distance will be 10 plus 4, that is 14. Here we are not considering the direction, but displacement will be 10 plus then minus 4, so it will be 6 kilometer. So in this case you can see that displacement cannot be greater than distance. It will be either equal or less than the distance. Understood? So in this way we can differentiate between distance and displacement. Now in next video we'll discuss about uniform motion and non-uniform motion.